Hi, this video is for the students of Infinitesimal Calculus 1, and we'll talk about negation of statements, or in other words, how we say that a statement does not hold. So we learned how to write statements with the signs for all and there exist. For example, for all x in A, there exists y in A such that y is less than x. What does this statement says? That for every x that we take in this set A, there exists a y which is smaller than x. That means that this set has a minimum. Has no minimum, sorry. This set has no minimum since every element we take, we can find an element that is smaller than it. And now we'll try to negate the statement. So in order to negate the statement, we need to change every time the sign for all appears, we need to change it to there exists. And every time the sign there exists appears, we need to change it to the sign for all. Why? For example, if we want to say the opposite of the statement, for all the cats, they has a house, every cat have a house. What is the opposite of every cat have a house? Correct. The opposite of every cat have a house is that there exists a cat that does not have a house. Maybe there are other cats that has a house, but even if there exists one cat that does not have a house, it means that it is not correct that every cat has a house. So we understand that instead of writing for all, we need to write there exist in order to negate this statement. We write there exist x in A, such that in order to write, instead of writing there exists, we write for all. Why instead of writing there exist, we write for all? Think about it like this. The opposite of there exists a black cat is all the cats are not black. There are many other colors, maybe not all of them are white, maybe some of them are blue or red or orange, but none of them is black. So the opposite of one of them being black is all of them being not black. So in order to negate a statement of the form there exists something such that something, I need to say that for all something, the other something does not hold. So for all y in A, and now I need to say the opposite of y is less than x. What is the opposite of y is less than x? Y is greater than x? No, y is greater than or equal to x. Because when I say I want to negate the statement, not being less than x includes being greater than or equal to x. So we negated the statement for all x in A, there exists y in A such that y is less than x. And we got the statement, there exists x in A such that for all y in A, y is greater than or equal to x. We said before that this statement means there is no minimum to the set. So we hope that this statement means that there is minimum to the set, and it is indeed what it means. Who is this minimum? X. We pointed on the x that is the minimum. There exists x that is smaller or equal to every y in the set. So this x is the minimum of the set.